Thanks, Nicholas. That's working, yeah. Last year was a very important year for robotics because, among other things, Bill Gates announced that Microsoft would actually consider robotic software very seriously in the future. And almost exactly 1 year ago, Sony announced that they would stop actually this robot, which is the Aibo. And I was lucky to work 10 years for Sony and to be involved a bit in this adventure. And I would like to, in this brief talk, to give you some insight about the key technology that were developed for that, and how actually this may give us idea about what could be the future of that domain, and how this technology can be reused maybe in other spaces. When they started this project in Tokyo in 92, basically, that was something, I mean, really new in the sense that they would come up with the idea of making a robot that will be in some way a useless robot. I mean, that would not be a robot that would do something for you that will be useful. That will be a robot you will interact with just for the pleasure of the interaction, just for the sake of it. And that was a rather bizarre idea when you think about it. And especially for the technology. I mean, when you have to make something which is very functional, which is for a given purpose, you have a lot of guidelines on how actually to do it in the proper way. But when you have to build an object which is meant to be interesting for its own sake, and which is meant to be interesting in the long run, then it opens many new questions, and we had to develop many technologies to deal with that. And among these technologies, the first are technology of presence. I mean, it's basically when you are in the first 5 minutes with an object like that, what happens? And it started, I mean, with various prototypes, and it changed over the years, and there were many improvements, change of design, the new ideas, more, funny robots, more threatening robots, and the key idea that this object was like a computer, but a computer with much more things. A computer with a lot of sensors, I mean, camera, touch sensors, temperature, microphone, accelerometer, distance sensors, and on top of these sensors, the possibility of actually going one step beyond it and start to do some form of aggregation and try to do face recognition, speech recognition, environment recognition, etc., etc. So that pieces of technology could actually sense something about what's happening in its environment and be aware of some aspect of it. So very rapidly we conducted experiments with children on how do they react for the first 5 minutes when they see an object like that. It's in French, but I'm gonna let you watch this video.
T'as l'impression qu'il voit là-bas? Enfin,
ouais, on dirait.
Est-ce que t'as un mot qui te voit toi ou pas?
Non, on dirait pas. Il s'intéresse pas.
So for those who understood French, I mean, in the first 5 minutes, this was the first time this boy was seeing the robot, and what he was doing was spontaneously creating a kind of experimental protocol. And what he would try to do was actually understanding what that robot was perceiving, whether it was perceiving the ball, whether it was perceiving its face, what he was aware of, what he was reacting to. So basically, it was about what was the type of world intersection there was between him and the robot. Was there something completely different, or would there be somewhere, maybe the object, maybe with hand gesture, where there would be an intersection? And this is, when you think of it, exactly what people do in zoo. When you go to a zoo and you watch people watching the animals, what they do usually is that they wave, they try to get a kind of joint attention, of connections, and animals which are the most successful in zoo are the ones where there is this intersection, even if it's smaller, but when the animal reacts to some kind of gesture. And that was the first thing for the first 5 minutes. What were they in common? Well, you see in the video, there was something in common, but not necessarily everything. I think it's interesting. I show you another experiment we've been doing, which was with dogs, which we've been conducting with a researcher in ethology, and we were exactly asking the same question, but for dogs. You had a dog that would actually eat a big piece of meat, and you had this robot coming in, and the big issue whether there would be a kind of world intersections between these two beings. So just watch that. Okay, so you see that this depends, of course, of the type of species you're considering. I mean, children have their own notion of world intersection, and in that type, that dog, which is a young dog, in that case, thought really this machine was in its space in some way. Okay, but that's just one thing. I mean, this world. I mean, that is the first prerequisite if you want to have some form of connection with that machine, to share something. I mean, it needs to be in the same space as you are. It needs to perceive some of the things you're perceiving. But I mean, is that sufficient to buy an expensive machine like this one? Would that be sufficient to interact with it over days, over weeks, over months? And probably not. And the second thing we've been working on very hardly was this idea that you need in some way to have the interest of the interaction increasing over time. It needs that, okay, should be interesting in the first 5 minutes, but it should stay interesting and eventually be more and more interesting over days, over weeks, over months. And in order to do that, it was very necessary that, contrary to most of the machine, this machine should evolve in some way as you interact with it. And it should evolve in a way which would be real. I mean, not kind of pre-programmed, like a movie that you could do fast forward or backward. It should be something that could not be fake, and that should depend really on the history. So I'm going to show you an early experiment we've been doing. That was like 8 or 9 years ago, when I was trying to teach some word to this robot. It was the first time this robot was seeing the ball in that case.
What is it? What is it? What is it?
So he said smiley, which was another name I taught previously. So I say this is bad.
Listen.
So he seemed to have learned the word ball, but I will try just exactly in the same condition to present the object and see what it's doing. And so in that case, he named it correctly. But of course, that doesn't mean he understands what a ball is, or that he actually would be capable of recognizing that ball if just the lighting condition changed a bit. And actually, that's what we've been doing for, I mean, that was like, I think, in 99 or in 2000. We were spending every morning something like 2 hours going over and over again, showing balls and other objects to that robot. That was, at the very beginning, very exciting, but a bit boring at some point. We had students also that helped for that. I mean, the idea would be to actually have the robot learning in many real-world situations, and you see that in the real world, I mean, a ball looks very differently. I mean, here you recognize a ball in all this image, but actually it's not the same color. In some cases it's occluded, in some cases there's a big light on top of it. So it was like a very long process, but in the end, what was more interesting in the process was not the fact that after, I would say, 2 weeks, he would be capable of naming more or less correctly 2 or 3 objects, but the fact that actually it would do that because of a unique trajectory that this robot would have done with you, and your robot would have been very different from the robot of your neighbor, because the thing you've been teaching to it would be really unique in that sense. And to some extent, a few years later, we saw that with the arrival for the IBO of the first IBO blogs that were produced by the IBO itself, where it would actually record what was happening in its own trajectory, in its own life, and it would actually post that in some form of a blog. And I just took a few random examples from the net of this type of unique history that all these machines were living in. So I think that was something very important in order to understand what could be the value of something which at the beginning had no real value, but for which value would only come day after day as you were interacting with it. But still, I mean, there was some issue, which was that with that type of approach, it was very tiring. I mean, this type of teaching, I mean, you could not expect people really to do that every day. And I mean, some people may do that, but even for me, I mean, that was a bit tiring. Okay, so we thought, and also in terms of learning, that was not the most efficient, because it was really trying to push things in the world of the robot. I mean, oh, this is a ball, it's interesting, come on, look at it. Okay, and we thought with my colleague Pierre Vaudeyer when we were working at Sony that there would be another idea which would be probably better if it would be capable of having some form of autonomous development, which more precisely would mean that the robot will look by itself and develop by itself, like young animals do, like babies do. And a key thing for that is that we try to program some form of intrinsic motivation for that robot. I mean, it will not do that for the pleasure of his master, it will do that for its own sake in some way. And so we come up with an algorithm that was capable of producing some form of curiosity for the robot, which basically means that the robot would actually have internal reward when he would learn. And he would look for things he would be capable of learning. So that's something a bit abstract like that, but it's very different in some way that learning because you will receive rewards by somebody else. Here, it will producing its own reward. And the very nice thing is that in that case, it could work potentially with many different situations. And I'm going to show you a few examples, not on the detail of the algorithms, but on what it would produce in the type of experiments we were doing. So one first experiment we did with that was just to add such a system control for the robot to learn how to use its body. I mean, you would start with a robot that would not know anything, basically. It just have like motors, and it would just try random things, and with the objective of learning. And learning things he didn't know how to learn. And with the type of algorithm we had, there was something which was interesting, which was that the robot would avoid things he knew already, things he would predict very well, things which were trivial or already learned, but it will also avoid things which were too hard for itself, things that no matter what it does, it was much too difficult for it to learn. And it will find this frontier, this limit between the two, which is the place where, I mean, when actually you do the thing several times, you learn. And that the robot can measure it by just watching whether it's predicting the effect of its own action more and more efficiently. So in that example, you just put the robot on the floor and you just watch for 3 hours. And typically it has no objective except just doing something interesting with its body. And typically in an experiment like that, it will babble for, kind of do a body babbling like that for something like 15 minutes or 20 minutes. And you see, and most of these movements have no effects, really. I mean, it doesn't permit to have a kind of interesting, non-predictable movement. Basically, you don't move with all these things. And at some point, it's just a slight change in the type of motor command lead to going backwards. And that was something very bizarre, is that in most of the experiments we did, I mean, going backwards was discovered first. I mean, there was something, it's more easy for a robot of that type to discover how to work backwards. And so that was this robot we're doing. And when they were doing that, they would actually do that for 1 hour. I mean, really exploiting that progress niche, I would call it. But at some point, I mean, going backwards was becoming boring. So it would actually change, and a slight change would permit to turn in that case. And it would actually discover and do that for another hour, basically, that a small change would permit to do some form of movement. And then, typically, in the last hours, for an experiment that would last 3 hours, it would try to go forward, because that was part of its sensory motor space that was not explored yet. And that was, for some reason, much more difficult for most of the robots we had. But at some point, you see, they would actually come up with something of that sort, which was definitely, I mean, not as elegant as the work that was programmed by the Japanese engineer in Tokyo when they launched the robot. But that was something the robot really had invented by itself in some way. I mean, it would really discover this way of walking, and not because it was motivated for walking, but because it was motivated to have action that would have interesting consequence for its body, or unpredictable consequence at that time being. So this is the type of thing we add in this type of experiments. And what was very exciting is that because our algorithm, this curiosity algorithm, was not about walking, it was about just controlling a sensory motor space, whatever that sensory motor space would have been. It could work with any other sensory motor space. And so we started to work with designers at EPFL in Lausanne to try to say, okay, let's make a playroom for that robot. Let's actually build more learning opportunities that it could or that may or may not exploit. And that, I mean, there are more than 20 or 25 objects that come up of this work. I'm just going to show you two of them because of the sake of the time. This one of them, and we just use exactly the same algorithm with that bicycle, and you could have the robot after again a few hours. I would develop something completely different. I mean, which is very far from the initial, dog-like approach. I mean, here we're something which is really different, which is discovering how to use a new tool, which was made for the morphology of the robot, but how to use it was not made for that. And then in the same line, there was two bright young designers, Laetitia Perrin and Tiffany Trippet, from that group that were really about making clothes for that robot. I don't know why they were doing that, but anyway. And we say, okay, we're making clothes, that's a bit silly. And then we thought, well, but that's something that would not be silly, which would be actually to permit to explore this kind of sensory motor exploration that we did for the walking, but in another medium. And there comes the idea of building a water suit. So that was what we wanted to build initially, but actually we came up with really like 4 months of prototyping and testing, and how much would the thing float, would not the thing float? I mean, so we put like wires. I mean, whether you had to. So this is of course a fake robot inside, but that was in the early prototyping zone. And then I'm going to show you, and then we did experiments in aquariums that we built especially for that, and I'm going to show you the first time we actually had one of these robots out in the wild, and doing exactly the same algorithm again. So that's in Paris, okay, in La Défense, and this is an early version. I mean, you actually have to strap it around, and then it's supposedly waterproof. And so he would actually, it's exactly the same algorithm than the algorithm for the walking, except that it's another medium, so it has to learn something else. I mean, walking on water, swimming or something is something radically different in that aspect. So we did, unfortunately it was a bit more difficult to do as many experiments that we did for the walking, so I'm not sure I could say that this robot really learned how to swim now. I mean, he has this type of, behavior, which, I mean, I can't guarantee it could reach any place, but I mean, it's progressing in some way, and so that was just one of the early videos, and okay, and of course now, I mean, we can go further. Now that he knows how to swim, I mean, so this is adapted to the morphology. So we have not built this one, but it's in the pipeline, probably. Okay, maybe more seriously. That's something very important in all the things that I've been saying is that, okay, here you've been seeing with one robot, we have this image in mind, and you think, okay, maybe the future will be with robots of that sort, which are not really like science fiction robots, but still they are a bit like science fiction robots. I mean, it's a bit like what we might imagine to have robots working around. And maybe part of the future story is about that, but maybe not everything, because all the technology I've been describing, actually, in some way, they're completely independent of robotics. And they could be applied to many, many other things. You need basically to start with some form of object which has a form of presence in your environment that can perceive and that can act. And many things can do that. I mean, your laptop can do that, media can do that, furniture can do that. If you have that, then the flow is very easy. Then you can build a history. You basically log what's happening. I mean, the most basic form of history is that. It's just like, you just remember, a memory. If you have a history, then machine learning techniques are basically, you can see them as a way of, through that history, building prediction. Basically understanding the structure of that history, understanding if all that happened in the past, given what's happened now, what will happen next. And that's what artificial intelligence is doing, and there are many techniques for doing that, from neural networks to rule-based systems, but they basically all can be used for this purpose. If you have a prediction system, then you may say, well, some states are better than others. That depends on your application. Maybe it's good to be whatever fast, or maybe it's good if the user interacts more with me, or maybe it's good if the user interacts less with me, or whatever. Or maybe in more exotic thing, like the thing we just tried, you can build even a kind of intrinsic value system where it's actually about learning to predict better in the future or something like that. But that doesn't matter so much. If you have this value system, then you can have basically autonomy, which basically means that if possible your device, whatever it is, can make some choice, then it can actually simulate the effect of this choice using its prediction system, and it will do the choice in order to optimize the value system that you've been defining. And so it works for robots, but it works for many, many other things. And I don't have the time now to actually go in each detail of what could be the future of that for clothes, what could be the future for furniture, what could be the future of that for books, what could be the future of that for even other types of media like music, which can be seen as that. My main message here would be that every everyday object can become a robot, basically. The other question is, should they, of course? And between the technological possibility and the actual interesting or desirable future, that's an open issue. Just to finish, and I conclude on that, I think it's something about really the topic of this conference, which is the place of technology in our life. If basically our future we dream of is about calm technology. I mean, technology which are in the background, which disappear, which we don't see. We just see the effect. They are like magic that have disappeared. Maybe this is not about it, because actually you may not want to have this form of autonomy, this form of surprise, this form of unexpectedness that were developed with this technology. But maybe this is not the future. Maybe you want chilly technology. Maybe you actually think that technology is something a bit exciting that maybe should push you a bit. Not just, being in the background and do just what you wanted to do, but sometimes come in your life and have a kind of unexpected effect. And maybe this is about the richness of life to have such form of technology. It's basically a matter of choice. At that level. And so I leave you with that question open. Thank you very much.
Thank you, Frederic. We have time for one or two questions. The audience?
So you spent a lot of time with this robot, and what happened to you? I mean, did you change your behavior? Did you have established emotional relation?
It's a bit strange in that sense, because I've been killing a lot of these robots also. I've been resetting a lot of these robots. I've been, you see, when you do this type of walking experiments, you don't do just once, you do 15, 20, 100 if possible. And so each time, you just, start again the thing. So there are anecdotes, of course, and the fact that you share an object like that, which has a presence, which has the capability of, for instance, just turning your head when you speak, or turning the head towards somebody else is speaking, which is sometimes disrupting you in your work, in the sense that he's been stuck in some place and you have to do something about that, or he's actually focusing his attention on something in your workplace or in your apartment. So all that gives insights. I could not say I'm the best cobaye to experience really what it is to have a kind of long-term relationship with such a device, because of the type of working relationship I had with it. But what we can say still is that there's something interesting with this robot, is that it's not a matter of illusion. If you know how the robot is working, and all the robot owners that I met in the course of these studies will confirm that. If you know how the robot is working, you not feel, oh, it's just that. You feel it is actually very exciting still, and you're very happy to watch it evolve and doing new things, even if basically you know the machinery around it. Or on the contrary, it's even better most of the time.